Okay, welcome everybody. We're going to be talking about performance of Phoenix applications. And this is going to be an interesting thing because I tried to make this short as much as I could. My first attempt had like 1 hour and a half. It would be like almost like a lecture on university. But yeah, I will try my best to be short, but at the same time, not confuse you enough. But that being said, it's going to be pretty much me showing a bunch of different tools for a bunch of different scenarios. And I'm leaving this thing here just because if anyone watching the recording, they can at least have a list of tools. I'm not completely sure this is an extensive list, but yeah. So let's get started. So first, I want if I'm going too fast, I can say, hey, can you slow down a little bit? Because I have to meet the 40-minute deadline. But whatever, let's go back. So what I mean by Phoenix application, I'm talking mostly about an application that, the traditional mixed Phoenix Neo thing with like a Postgres database, Acto and your context, doing your core domain. And then your presentation layer can be anything, like it can be like a Absinthe API, some controllers for JSON APIs. The example that I built today is built on LiveView. There's some JSON, there's some controllers to do like login because I just used the generated stuff. And I'm going to start with the data model, just so we have like a base understanding. So this is a simple kind of like Notion-like application. So you have posts, and posts belong to topics, and topics is a hierarchical structure. So a topic can be a root topic, or can be a child of another topic, that parent ID thing. And then the user and user tokens part is just like mix Phoenix gen off because I'm lazy, right? And then there's this post contributors just because we have an end-to-end relationship between posts and users. And also one of the contributors of a post can be the author, the original author, whatever. This is the data model. Let me show you the application. So just a quick tour. So I'm going to log in, demo, example. I'm using a split keyboard. I started doing that, and now it's hard to type in a normal keyboard. Yeah, bear with me for a while. Okay, so the application, you have topics. You can like create a new root topic. There's this view as tree that generates the whole tree of topics up to 5 levels deep. And you can navigate to topics. A topic can have some posts. Post is just a markdown thing with the list of contributors. And you can have child topics. I also create some problematic stuff here, like this one here. There's a lot of contributors, not in this particular instance, but in this one there is a huge topic with like a lot of posts. Because I want to make it slow, right? So, all right. And you can also there's some weird stuff. There's this word count report that I had to cut it off of the presentation to make it short. But yeah, there's a few things here you can delete, can create, pretty much basic stuff. Like imagine this is your knowledge base or whatever. All right, so this is our application. So let's start on performance. And I've been trying to create a mental model for me so I can present here. So it was a good exercise for me as well to think about like the steps on how you will improve the performance of an application. Because over the past 2 months, I've been doing that in my current work. We had this query that was really, really slow. We started having a timeout, and then we went through this process of trying to improve it. And I tried to put like 3 main phases on improving performance of anything. So the first part is, oh my God, are we good? So whoever's tuning in right now, because you lost the whole thing, I just demoed the application. It's fine, you don't need that. The application is bad on purpose. All right. So the past 2 months I've been thinking about how I've been working on improving like one specific part of our application, and I've been trying to create this mental model on how that works. And I thought about these 3 distinct processes, and it has distinct tools that you use in different parts. There's some overlap sometimes with some of the tools, but first is discovery. Like how do you discover what needs improvement, what is getting bad, or there's some subjective to it, like how slow is slow enough, is too slow or fast enough. But mostly this comes from 2 different places, I would say. One is user reports. Oh, this thing is just slow. This thing just getting an error and then you check and it's a timeout. So that's the worst type of discovery, right? Like you discover when it's already bad. And the other thing is from monitoring too, like the whole application performance monitoring tools or your Grafana stack, whatever. But the idea is that you should be able to see some, outliers that are starting to become slower than the rest, like than your baseline, and then maybe this is something that I need to take attention of. This is a complex part, and I'm not going to be talking too much about it. We're going to use a little bit, but I know exactly where the problems are on the application. Otherwise, this would be like 3 hour long or a 3 week long thing because finding out is hard. But yeah, so after you find out where it needs improvement, there's the part where you want to understand why it's slow, and the profile part, right? And here, there's a bunch of tools that are gonna give you insight on how and where you need to look at. So this is the profile part. I mean, I just came up with this name, and everybody says profile, but I came with the name of the phase, whatever. So there are kind of like different tools for different scenarios. So one of the things that I'm going to talk a little bit about, which is kind of related to monitoring, is distributed tracing. So this is why there's a little bit of overlap. But distributed tracing is one tool for like a more generic thing. And there are like language and VM specific thing, like profile tools. Like there's a profiler for Elixir, for Go. They're going to be specific to the language. And also some database provide some profiling, tools like Postgres. I think it's an SQL thing, but everything is a little bit different. Yeah, Postgres has the explain, analyze that gives you a query plan on how it's going to execute the query. And then there's the part of optimizing, and I'm trying to collect a few techniques and try to classify them because a lot of the stuff that we did was kind of like similar. So there's going to be like batching or preloading or just adding, a new index or, making faster algorithms. Or I haven't put it here, but sometimes the normalization of data, like, yeah, in university we learn, we need to have normalized data. I don't know if they still teach like that. But a lot of times you need to have the normalized data just to have faster access. So there's a collection of techniques that you employ to solve the problem. We're going to look at a few of them. All right, so let's talk about discovery, and let me just, So I'm not going to go too deep into that, but I want to highlight two things. And one is open telemetry. For a long time, whenever you want to like have observability and instrumentation on your application, you're using, I don't know, New Relic, you're using something like that, and then install a bunch of like vendor-specific libraries on your program just to instrument it. AppSignal, whatever, Elixir library. And the reason why this is really, really bad is because it's a vendor lock-in, and replacing this code is just a mess, right? Like, and sometimes you're gonna have code for you changing vendors, and for a while you have code for instrumenting the two different vendors. So OpenTelemetry is this set of standards and concepts, but also SDKs that are community, they're managed by a community, so it's open source. But these SDKs are not vendor specific. And so I'm not gonna go too much into detail, just gonna mention that like there are three main things, metrics, traces, and logs. While metrics helps a lot on the discovery, I'm gonna focus more on traces, which is kind of a log. So that goes to distributed tracing. So just explain the model a little bit so we're not completely lost. So the idea of a trace is this full story of a request on your application. So instead of having logs on each application and you have to somehow correlate them, the idea is that you have a structure that you can correlate these logs, these events that are going through your system. And this gives you like this nice view of, even if you have like multiple services, that's the distributed part, I can see, I received an HTTP request here, I did a database query here, I called another service here. And all of these requests, they become part of the same trace. And each part of the execution, even one per service or many per service if you want to have multiple spend this slice of time. And so this is going to help a lot, and there's also events. But we're going to look a little bit on distributed tracing just to show you how, because the reason why I'm talking about that, because this is useful for discovery, because you can generate metrics and things from that, but it's also already a step into profiling. You already can see some bad usage patterns. All right. And this is just two recommendations that I just want to, I want to put some distributed tracing. And I'm going to make two recommendations. There's a bunch of things that support OpenTelemetry, that support distributed tracing. One is Grafana Stack. It's an open source thing. It's the one that I have in my Docker Compose here to show you. They have a bunch of things. There's Grafana, which is the UI. There's a bunch, we're going to be using Tempo, which is this distributed tracing storage, and query language for things. Doesn't matter much, and the other one is Honeycomb, is a vendor one, but they fully embrace OpenTelemetry. So I don't know, I just think they're quite cool. I don't have any relationship with them, just one of these vendors that I quite like their product. So all right. Before we jump into that, into trying to improve the performance of the bad application that I wrote on purpose, there's a big difference when you're trying to understand performance on production versus development. So it becomes really, really, really hard for you to, it runs fine on my machine, right? And the reason for that is that there are three main things that can make your application slow that sometimes you don't have in your local development. One is the size of the data, right? If you have an algorithm that is like n squared or whatever, it's going to get worse according to the size of your data, right? I mean, unless it's O of 1, you're always going to get worse with the size of the data. And sometimes in production you have like millions or tens of millions or hundreds of millions of rows, but then in your local machine you just have this seed script that create like 1,000. And you're not going to be able to see the bad things become bad on your machine. The second one is latency. When you have you have multiple services, but you're running them all in Docker Compose. And they run exactly on the same machine. Latency is like half of a, I don't know, 1 microsecond. I don't know. It's really not a lot of latency. But when you are in a cluster environment, like even if they are in the same network, they're still going to have a little bit of latency, like half of a millisecond, 1 millisecond, 2 milliseconds. And some problems like n+1 queries, this 1 millisecond, if you're doing 1,000 queries in sequence, it's just going to become 1 whole second. So latency is important. And the other thing is load. A lot of problems when you have like shared resources, they just become like write database locks, right? When you're doing writes in the database, you're locking the rows. If it's just you using the thing, not gonna become a problem. But when you have 1,000, 100, 1 million users using it, then it can become a problem. So because of that, I'm going to try to simulate production. I'm going to show you a few tools that I set up here for simulating production. So I'm here on my system running, and I'm going to do 2 things. First, I'm going to change to use a larger data set that I already created. So I'm just going to change the database here. So the one that I showed was quite fast. I thought this is a bad application, but everything was loading fast. So we're going to see this larger database that I already created. By the way, the whole thing I'm going to post online. If you want to check the code base, you can see the script or whatever. It's not that important. Okay. The second part is that I want to simulate latency. And there's this nice tool called ToxiProxy from Shopify. But it's this thing. So my Docker, instead of exposing Postgres and this microservice that I created, instead of exposing this directly to my local machine, I put them in Docker Compose, and I put ToxiProxy, and I have this, so it's kind of like a proxy that sits between the things, and I can have I have the systems here, and you see I don't have any toxics, but I can simply add toxic. I have the script here to just add some latency. So I'm just adding 1 milliseconds of latency. So I'm just going to do scripts add toxics. All right. So now I have some latency between my database and my application. It's between 1 and 3 milliseconds. So this is another tool that's quite cool for you to simulate. And the second thing is load. And while we do the talk, I'm going to be running K6. So K6 is this nice benchmarking load testing tool from Grafana. So again, don't worry too much, but I'm just going to generate like 10 concurrent users doing stuff in my application. So I'm just going to come here to load test. And I'm going to do run. So just do like this. I hope I don't break anything. Just going to run like 10 users for 20 minutes, which I hope to be almost finishing my talk in 20 minutes. So yeah, so this is running 10 users using it. All right, so now we have a production environment. So now we want to profile stuff. I'm also going to show you a little bit of Grafana, so we can do a little bit of discovery. So, okay, I just have to log in again, demo example.com. You can see now that some stuff is going to be quite slow, so that too many contributors now takes a while to load because there's a lot of things and there's some latency between the database. And I mean, this is the n+1 problem. So this is doing a lot of queries, and the 1 millisecond thing is just adding up. And we also have the huge topic also now takes a long time to load because now also it's a bigger data, like 500,000 maybe. I don't know how many posts I put here. A lot of them. So yeah, so some stuff are really slow. And if I try to open this view S3, forget, it's going to take like 20 seconds to load. But yeah, all right. So let's start by looking at the performance of our system. And we're going to be looking at Grafana. Can you read this good enough? Okay. So we're going to be using Tempo. As I mentioned, Tempo is also a Grafana library. I mean, I'm quite a fanboy of Grafana. Not sponsored by them or whatever, but I just like the things they do. All right, so again, I'm not going to be able to explain a lot about this, but I can filter by things. For example, I can filter by HTTP, just one T, .root, for example, and I can have all the roots that I have here. And I'm going to be using just this filter, but you can do a bunch of filters. You can filter by latency. You can filter by a bunch of things. So let's get, I already know the one that I want to look at, which is the post ID. All right. So we're going to run the query. Let's just make sure that it's last 15 minutes, run query. And we see a few of them that are quite fast. But I want slower. I want slower things. So I can come here and I don't know, just give me the things that are bigger than 1 second. Oh, so you see it now that I have a few of them that are taking like 6 seconds. So this seems bad. So I can come here. I don't know how good you'll be able to see. Yeah, Okay, so this is the trace, right? So this is a trace, and each of these things are a span. And you can see this one has like 1,000 spans, and this seems weird. And when we look at this already gives us some information about what is going wrong here. And we can see that we have, 1,000 requests. This is clearly an n+1 problem, right? So this too gives us insight on that, and we need to fix it. All right, so let's start by fixing it. Okay, so to be honest, for n+1, a lot of times all you need is this. You don't need any specific Elixir, profiling tool or whatever. You just need this. It's clear that there's a problem. But what is cool about this is that you have a lot of metadata. So this is kind of like just a really large. You don't have to worry like metrics about the dimensionality of the data that you put. So you can just do like wide events and put a lot of data. And in fact, you have a lot of things. So here's like a live view related thing. So I know this is something related to post live show. I also see that this is after this. So it's after the handle params and after the mount. So yeah, this is a weird thing about live view, but this just gives me an indication that this is happening on the render. Like I render the still things, then there's some child components that are rendering after that each one of them are doing some things. I can even see like the query, so this is the database query that is being used underneath. So there's a lot of things that you can already figure a bunch of interesting things of what is going on. I can see here, I can see I have the URL here, so I can go there and see which topic, which post this is the problem. So localhost. So I can come here and I can open and, well, it's taking a while because it's slow. To load, and yeah, we can see that it's a too many contributors thing. All right, so let's fix it. So we know this was related to the post show HTML because we know that is in the, yeah, we know it's on the render thing as I mentioned. So there's a little bit thing that I'm cheating to save some time, but yeah. So we can see here that we do this for thing, and we call this live component. So there's this user badge component. So let's just see what this user badge component does. User badge component. And you can see this is a live component that I'm just doing this update, and I'm getting the user by ID, just load the name and call it display name. I'm not the best programmer, but yeah, of course there are a lot of different ways. But what is happening here is that I need to load this data in batches, right? And there's like Acto has repo.preload or whatever. Absinthe has the data loader thing. I'm just going to show one thing that is kind of new in Phoenix 0.2.1, which is update many. So it's exactly the idea that instead of each component doing its own query, you have update many. So it's a new callback. I think it's 0.20 that introduced it. But instead of receiving one assigns and one socket, I receive a list with all of them, and then I can batch everything together. And to be honest, it was kind of fun because when I was reading the documentation, this is almost exactly what we're doing there, like loading users. Yeah, whatever. So I already prepared a commit for that because I'm not that mad on doing live coding. So git show fix n+1. So can you read that? Like how bad is to read this? Good. All right. So yeah. So pretty much I'm just adding this function to my context, to my Phoenix context. Pretty much just a batched user get, so I can get a lot of user by ID. And then I'm just changing the update. Like it's almost similar the code, but yeah. Instead of doing for one thing, I just do for everything. Again, you can check that. So let's just git cherry pick fix n+1. All right. So fix n+1, and that's good. All right. So we profiled and we optimized it. So for n+1, we want to do batching and loading. Instead of loading one small things a lot of times, I want to load all the small things once, so it's less queries. All right, and then if I come here and refresh this page, it should be quite fast. Yeah, much faster now. All right, so that's cool. So let's look at another problem. And this is going to be a little bit trickier. So I want to go back here, and again, discovery. I'm just going to cheat because I know exactly where the problem is. But I want to get anything that's on that tree. That's not great UI. Yeah, constrained on size. It worked well on my 140p monitor, but yeah. All right, so I want to get anything that's on topic tree. And you can see that it's taking like a lot of seconds, like 16 seconds. And then I can open this, and let's make this small. And you can see that this trace is a little bit different and interesting. So this is where distributed tracing can become a little bit problematic because it doesn't automatically trace everything in your application. You kind of have to instrument it. There's some libraries that instrument some famous, like there's OpenTelemetry Phoenix, OpenTelemetry LiveView that already do some of the spans and traces for you. But you would have to instrument, like if you want to have a trace of every function, you would have to instrument everything. So you can see here there's an interesting thing. So I have this, this topic live tree mount callback. And you can see that it's calling this query, which is also quite slow, 2 seconds. But you see that the bulk of the thing is happening after this, and I have no observability on that whatsoever. So let's go back to the code. So I know it's something happening on the tree live mount, if I can type. Oh, I think it's just tree. Yeah, it's live tree mount, whatever. Okay, so I can see that on the mount thing, I pretty much don't do a lot, but I do this topic tree and I call this tree menu. So what you do here, you come here and then try to see which part of this is the worst one. You can run locally, generate data. We're gonna cheat a little bit again. So we kind of like figure out there's something bad with this topic tree thing, but we don't know exactly how to make it faster. So I'm gonna open the topic, the content thing, and I'm gonna go to the topic tree. So you see this function here, you see like, okay, so this is doing some stuff, it's doing the query, so that's probably the query that was showing up there, and then it's doing some recursive function. I guess the problem is here, but what is the problem? I mean, this code is simple, we can probably get from here, but imagine this code could be a complicated algorithm with a bunch of init functions. So here's where comes some profiling tools, and I want to just mention 2 of them. So one is fprof, and the other one is iflambe. So fprof is a tool that is built into OTP. So OTP has a series of like profiling tools, fprof, eprof, cprof, dbg. So these are tools that are built into the OTP, and they are able to use something called the trace BIFs or something like that. And then it pretty much can trace all the function calls internally and give you this nice detailed trace. It doesn't give you a nice format, so I'm pairing with 2 other scripts, actually 3 if you think about. So one is orgrind, so this converts the fprof trace into a call grind, which is a format. These are old scripts, just so you know, like 6 years old or whatever. I mean, in compute time, this is like forever. And so one orgrind is this thing to compile to call grind, which is this vol grind project format. And one is gprof2dot, which converts this to a graphviz file, and then I'm using graphviz to generate some PNG. All right, so just some tools that I'm going to show, but the reason I'm showing 2 different things is because they have 2 different ways of visualizing data. So I have this script called, well, fprof, and pretty much, okay, so if I figure out where's the problem, you want to understand why the algorithm is low, so I just did some kind of like generation of topics. So this is just like building data. And then pretty much the whole profiling thing you do is this. So you can do like fprof apply. You can use fprof in production, and you can attach and listen to actual production stuff, but of course there's a performance improvement, performance degradation. So that's why there's the cprof and eprof, they're kind of like lighter weight. I never run these things in production. Once I tried a little bit of these things to like locally, but yeah. But okay, you have this thing, you're running locally, you generate a bunch of data, and then you pass fprof apply, just pass the argument here, and save the file, and then there's this just scripting to use orgrind, gprof.dot, and then graphviz to generate the thing. And I'm not a madman to run this thing now, so I'm just going to show you the results. All right, let me just minimize everything. Benchmarks, not benchmarks, profiling. Where's profiling? All right. Okay, so I have this, I generate for 2 different levels. So one is one topic with 10 things and 10 child topics, and the other one is, well, 1,110 topics, like 3 levels. So let's just take a look at the generated graph. So, and you can also, there's also this other tool like qcache grind that can look at the vol grind generated thing, and there's more interactive. But I think this is enough for what we want to do here. All right. So this thing just gives you this graph of all the calls that you're seeing. And if I'm not mistaken, this number here is the accumulated time. So it's the total time the whole thing spent on this function here, like this is the root thing. And then in the parentheses is the thing that is spent only on this particular function and not on any of the child functions. So you can see that, yeah, so there's some, this is the 3 level, sorry. Like, let's go to the 2 level first. Okay. Right, so you can see that the topic tree function here, there are some other stuff going on here. But yeah, you can see the whole call graph. You can see that the topic tree calls, the do topic tree calls map new, that calls from enum, that calls this anonymous function, which is just the extraction of this function, so it's a recursive function. And you can also see that this function also calls enum filter, which calls this other anonymous function here. And you can see now that it's kind of becoming clear the problem here. it took me a while to understand how to read these things. But this number here I think is one of the best. So this was called one time. And then this was called 110 times. So this seems to be called once for every item in the whole topic list. And then you can see here that a non-filter list was called 12, whatever. This is pretty much 110 squared. So you can pretty much spot that this is an algorithm that's probably n squared. So this can give you an example. And then if you look at the tree, you can see a similar behavior. You can see that it calls around 1,000 times, and this calls around 1,000,000 times. So yeah, so this is probably an n squared algorithm. So okay, so this is the end of profiling with this tool. I'm just going to show the other two. So Flambe is this tool that generates this flame graph. So flame graph is kind of like the trace that we saw. And yeah, so I have another, it's similar to the distributed tracing, but for more lower, like this type of whatever. So it's a similar script. There's this generation thing here. And then it's pretty much the same thing with minor, like this I put the module function argument in a tuple instead of being different arguments. Pretty much the same thing. So I just called it from B, do apply. I think this also uses some BIFs underneath. I'm not completely sure on the implementation, but generate this BGGG file, that many Gs. And then I already run this because again, not that madman. And I'm going to show, where is that? So there's this other cool speed scope, which you can open these BGGG files. And I'm not going to open the tree level because it kind of like froze my computer. It's like a 1 gigabyte file. So yeah, trace data can be big, so be careful. So I'm going to open this thing here, and then you can see that it also gives an interesting visualization of what's happening. Like from here, you can already see that this thing here, this filter list here, is the main block that was repeated a lot and takes a big chunk of time. Like this is too small to be that the problem. You can see that this thing here, like it's kind of like the main block that was repeated is repeated here. So this gives you an indication that maybe you can make this thing faster. And yeah, you can go down, you can see specific things. So it's a nice thing to navigate. Different kind of view. That other one is more like it looks just at the functions. This one looks at the calls. It's more like more granular information. All right, so to be honest, this we already know where the problem, like you kind of know where the problem is. So we come to the code, we go to content, and maybe instead of filter here, I can maybe do some preloading, convert this to a map, and then I can optimize it. All right, so this is where profiling ends. And now it's a funny thing because whenever people think about performance, the first thing they think about is micro benchmarks. But micro benchmarks is not something you use to find the problems. It's something you use to, when you are optimizing, already optimized, to compare to different solutions, right? Like it's not really something that, I mean, it can give you some insight of like, when I grow this thing here, it uses more memory, more CPU, but it's not a great tool to understand where the problem is coming from. But I'm gonna show you either way. So there's this other tool called Benchy. And I have the script, again, pretty similar, topic generation, but in this moment I already implemented the new implementation. So I had the old one, I just copied here. And then I can be smart, I can just do a group by, like do some pre-processing, build a map from parent to all the children. And then I can, instead of doing filter here, I can just do map cat, and that's gonna be much faster. It's gonna be O of n log n. If you have enough memory, just O of n, but yeah. So Benchy, you pretty much do some, you can do some inputs, generate some data. You can just pass some things here. I also have this Benchy HTML that generates a report. And in the end, when you run this, you get something like this. So this is the HTML report. You get also some console reporting. But here you can see that the new implementation actually, when this is just with 10, just one row, just 10 items. You can see that it actually is not that big of a deal. It's actually much worse in terms of like deviation. Like the new one, the new one just like the maximum is much bigger. Even though the average is a little bit smaller, it's just too complicated. But as soon as you add more stuff, like with 100 things, it's starting to become a little bit better, like in iterations per second. Again, there's some deviation. The maximum, I think, still worse in the new one. But when you start getting to the thousands, you can see that it starts making a really big difference. Now the deviation is here, but like, it still have, I think, a bigger deviation. No, it's lower now. But yeah. But yeah, you can see now that the difference is kind of like crazy. Like, so it's like 10 times, 100 times faster. And if you have like 4 levels, I don't know, it just become really clear. So benchmark is a great tool for you to compare two things and see, yeah, this is clear better than that. Of course, that example, you could pretty much just do that by just thinking about it. But you could have a more complicated algorithm, and it's going to be like nuanced on, like you'll not be able to figure out the complexity of the algorithm just by looking at it. So that's where benchmarking can be quite handy. All right. So again, we can just go here in the Git cherry pick, optimize topic tree. I should have shown that, but whatever. Optimize. Yeah, it's just that change that we saw the implementation, and it's still going to be slow, just so you know, because it's still loading all the topics. But yeah, we could improve that later. Yeah, but now if I reload this thing here, it's a little bit faster. I think it still takes like 3 seconds, so not the best, not my best work. But yeah, it's still, 3 seconds is much better than 20 seconds. Oh, now this is just, yeah. The problem with live view is that whenever you change code, it keeps reloading everything, and then I have this really slow thing, so whenever I save the code, things just get bad. All right, so let's jump to the, and also with still 10,000, but like 2 wire levels, it just became like a bigger difference, whatever. All right, so now we're going to look some SQL queries. So we looked at something that was between your application and a database, just doing a lot of queries. We looked at something that is just Elixir, but I would say that for a lot of people, the main problem is going to be actually in your database, because most of the applications that we do is just data heavy thing. Most of the load is on the shoulders of Postgres or MySQL, whatever. All right, so let's start again. Let's try to start with the profiling. So I want to get, I already know again, you'd find in a different way what I want to get on this topics ID. And I have some of them that are quite fast, but I have some of them that are like a little bit slower. So you see some of them are like 1 second. And then again, it's cool, you can come here, you can see, so it seems that this one is slow, and then you would see the other ones, and you would figure out that, oh, just this topic that seems to be quite slow. So again, you can come here, you can open localhost topics. This thing here, you can see, okay, it's this huge topic. And then you could do some SQL queries and figure out, oh, this seems to be like a big topic compared to the other ones, and then this gives some information. So just by looking at the logs, right, it is pretty much just logs, but in a structured way. You can get an idea, and then you can come here, and this is where I think it's quite cool. You can look at this thing, and like there's a bunch of queries happening. Which is the slow query here? You can see that clearly on this distributed tracing thing, this is the query that is slow. You just click here, and you can open here and you can say, okay, so this is the query that is quite slow. So let's just try to understand this. So I'm just going to copy this. I'm going to open a connection to my production database, and I want to run this. And there's one trick that I learned. To be honest, I've been using Postgres for a long time and never knew about that. But I always thought that this like dollar thing was an Elixir thing, but it's actually a Postgres thing. There's this thing called prepared statements. You can just do prepare list posts as this. I don't know. I just think this is cool. Maybe obvious for some people. Oh, wait a second. What? Oh, if I connect to the right database, that's going to work. All right, so prepare a statement, and then I can just come here and I can do execute list post like a. So this just lives on the connection. So if I disconnect, I have to prepare the query again. But this is kind of like a view or a function or whatever, but it's just on the. But yeah, but now I can get the thing here. I can run here, and I can. Oh, thank you. Pair programming, the best. All right, so if I run this, you can see it's a little bit slow. If I change to any other ID, you can see that it's quite faster. So yeah, it seems that that's actually the problematic thing. I don't want to execute that. Okay, but now how do I get some insight about it? All right, so you can just, if you know a little bit, you can, I can just do explain, analyze. Oh, fine, you can do with, because I did it with S yesterday, I thought it was wrong. Oh, they don't discriminate between British and whatever. Okay, that's cool. So this gives you like this text thing, which is for these small queries is a lot of times is enough. But I was having this thing with a lot of joins, a lot of things connected from multiple tables. It was just impossible to get any meaningful insight about it. And this is where I found out about this. Seriously, this saved my job. Maybe I was going to be fired if I didn't do that. All right. So I just found out about, if I can find here. PEV2, seriously. I don't know who did that. Maybe it's this this is a company, whatever. But thank you, whatever. This is really amazing. So this is this Vue.js application that you can just send your explain, analyze things, and they're gonna show you like an amazing thing. I'm gonna show you. I've been using this data grip thing, but yeah, data grip just too heavy to run on my machine when I'm doing a lot of other stuff. But yeah, you can also just download the HTML thing and then do it locally, but I'm going to be using their service. I mean, they save my query, so I don't know. My work, I didn't do it because we didn't want to, like, you know, compliance reasons, whatever. But you can just run locally with the index.html or with the data grip extension. So the way that it works is that instead of just doing explain analyze, I'm just going to do this explain. I didn't know that there were all these options for explain. But you can just do this instead. So explain, analyze, crossover rules, buffers, format JSON. So when you do that, instead of generating that thing, it generates the JSON. And then you come here and you paste it. And let's just go list posts. You can see I already created a training the other day. All right. So, and now it gives you this nice graph that you can pretty much screenshot and pretend that you know what you're doing. But yeah, no, so this gives a lot of information. So when you have like a lot of joins tables, this is going to become like this tree, and it becomes really clear. So another thing that's clear, like this, the size of the arrow here is like how many rows pass through here. So I can see that this index can pass like 500 rows, but then of course we're just getting 50, and like 50 pass through the sort. So it seems like I don't have a index that is optimized for this specific sorted query. So I can just come here, come here and do create index concurrently, and I want to, well, on list posts index, whatever. You would do that in a migration, but yeah. On posts, topic ID, updated at desk, and ID desk, whatever. All right, so I just create this thing here. If I know how to type, oh, semicolon, all right. So just create the index, and now if I run this, you can see one was much faster, and I can come here again, and I can paste it here, list posts with index, all right. You can also paste the query here, so people, when you share this, people will know, whatever. Now you can see that it's just an index scan, no sort, so because it's getting things already sorted. You can see that it's only hitting 50 rows. You can see now the execution time, I don't know if you can see that, but yeah, the execution time is 2.65 milliseconds. And oh my God, this is horrible. And if you come here, the other one was like 1 second. So yeah. So yeah, again, oversimplification, a lot of times you just need to create an index. I just want to share another thing that I found. Sometimes it's hard for you to get these things from the query plan. So I want to show this delete post. So I have this feature delete post, and I made this low. So you can see like this thing was taking 256 milliseconds. But when you look at the trace, and you look here, you see, oh, spend 0.1 milliseconds here, and then it's 1 millisecond here, and then we're like, I had something similar, like, where is these other things coming from? And it turns out that for whatever reason, if you go to the raw here, you see that the triggers, they're not included here. So pretty much I had the post contributor thing, and I didn't add an index. I just added an index from like user ID, post ID to make it unique, but I didn't add an index post ID, user ID, or just post ID. So when I'm trying to delete a post, it has to do a sec scan through the whole thing to find the things that would violate the foreign key, and then do whatever the condition is, whether it's cascade or nothing, and just return error. So this is what is taking too long. So again, if you add an index, I'm not going to do this, but if you add an index, you can see now it's much faster. So a lot of the times you can need to be. Just one fortunate thing is that whenever you're doing like Phoenix generated stuff, let me just do posts, create posts. Phoenix or Acto, I don't know who's doing that actually, but is smart enough to just add the index for all the foreign keys. So just make sure I think MySQL by default foreign keys have indexes, but Postgres doesn't. So, and it's kind of like, I don't know why you wouldn't want a foreign key. Maybe it's because you want to have another index and like more composed one, and you don't want one with just that field. But yeah, just make sure that all your foreign keys have indexes. Otherwise, you're gonna have these hidden things that, why is this taking so long? But yeah. Fortunately, the generated things is that already. All right, And to be honest, this is, yeah, I forgot to remove this. We don't have a lot of time. But I was going to show that. That's going to be for the next chapter. So just to wrap it up, I just showed you 3 types of problems. So one is a really common one, which is n+1. The tracing alone was explicit enough for you to understand the problem. The solution is normally some batching, preloading things where you want to, instead of doing many queries, you want to get all the data that you want and do one bigger query. For slow code, this is, I mean, to be honest, I've never seen that being that big of a problem. There was once that we just replaced a few things with some graph libraries to do a few algorithms, but most of the times your application are slow on the database or n+1 query. So I don't think that, I just wanted to show because I think school, the fprof and implement thing. And well, the solution will vary. You're gonna have to remember all your algorithm classes and books. And slow query, there's a lot of different ways of solving that. But again, the zero tracing give you a good idea of where to look at. Postgres Explain is amazing, and PEV2 for me, that was the game changer too. And well, the solution will vary. You want to add indexes, do denormalization. Yeah, sometimes you want to have an index, but data is normalized, so it's another place. So in order to have the index, you need to denormalize the data first, like copy the data over to another table, or do some like materialized view, whatever. And yeah, sometimes sometimes adding more conditions also help a lot because you can help Postgres filter the result set and have to work with even your algorithm is low. If you have less data, is better. Yeah, again, a bunch of tools that I mentioned here from ToxiProxy K6. Yeah, if you want to look them later. If I forgot about one, yeah, you can ping me and then I can give you the information. So to be honest, that's what I wanted to have for today. Again, I tried to make it smaller, but yeah, there was a few things that I had to left out. So yeah, thank you.